next step of this exercise is going to be to go ahead and complete our MODAPTS analysis. I've given you a special MODAPTS form for this. You can find a link to it in the assignment. I also put one here on the summary table at the top of the assignment page. If you click on it, it should open something like this, and you'll see it's got kind of standard fields in it for including your job documentation, which you should always do for any MODAPTS or time study analysis, because we see the workstation is a really important part of the method and the time required to complete an operation. I've actually gone ahead and pasted in a couple of figures at the top of this just for your convenience, so you can refer to them while you're doing your MODAPTS analysis. One is some pictures of a subject performing each segment of the task, and the others, of course, is the CAD model that we constructed. So let's go ahead and take a look at this. You'll notice this is a little bit different than the MODAPTS table we used before. It's different in several ways. First of all, you can see that I've got the move and the terminal elements in separate rows, as opposed to having them consolidated the way they typically are in most MODAPTS tables you look. You'll also see that there's actually some, if you hover over the cell, it actually gives you the key codes that we're probably going to use for this analysis. So again, that's just intended as kind of a convenience for you. Another reason for separating them, though, is that we're going to be looking more closely in a subsequent part of this exercise at the force that's being exerted in each parts of those or each of those steps. So this allows us to partition the forces a little better. So let's go ahead and get started and see what this is going to look like. So we'll just start out here with the subject or the worker reaching to get a clip and reaching to get a card. And as we talked about before, based on the distances, we classify the reaching to get the clip. Remember, the can's going to be coming from the previous bundle of cards with a clip as an M4, and we'll call it a G3 to grasp the clip, whereas the left hand is going to be doing an M3 G1 because of the way the cards are presented to the worker, and then an M3 P0 to put it in place. So we'll come down here for our motion code for the right hand. This will be M4, and the terminal element here will be a G3, and the frequencies for each of these are 1 per cycle. So that means this one gets 4 mods, and this one gets 3 mods. And then we'll go to the left hand. We've got M3, and we've got G1, and again the frequencies are 1 and 1, and then we've got times for those will be 3 and 1. We'll apply our simultaneous motion rule to get the total, to combine these and get the total time for that action of the right and left hand together. You can see that we've got a high demand or high control terminal element for the right hand and a low terminal element for the left hand. So that means the combined time will be based on the one with the high time, or the highest time. So this will become an M4 G3 with 1 cycle, and the number of mods here for that will be 7. So now let's go to the next step. Now, while the left hand is still working, the right hand actually, they're both going to move these together at the same point, so I'll strike that. So we've got the right hand is going to have a clip in its hand, and it's going to move it into position. If we go back and look at and this is a case where actually it's maybe even a little easier to get this information from the CAD model than it is from looking at the pictures. But remember we had actually one movement where it kind of brings it up to the edge, and that's where we're going to apply the force to open the clip. So this will be an M4 again, as you recall from our previous discussion, and it will be followed by a P0. And the second one for the left hand will be an M3 P0. Oops. M3 P0. Nope, P0. I have a hard time getting the PQ. I'll get this right eventually. P0. Okay. So, and the frequencies for all these are 1. And the number of mods are 4, 0, 3, and 0. And of course, combine these, we got 2 low terminal elements, P0s. So we take the longest one again. So that's going to give us an M4 P0. One frequency of 1 and a total time of 4. Now the next element, the left hand is just kind of waiting there. It can take its time, so it gets to rest a little bit. The right hand is going to have a M1 to open the clip, or to move the clip into position and open it at the same time. And then it's going to also have a P5. Remember, we have to put this in the exact location. And we're going to give this an X4 for extra time. Okay, and that happens once. So the total time for that is going to be 1 plus 5 plus 4, or 10. And we've got the get put down here is going to be, I'm sorry, I have a habit of putting these all in one line. Sorry, undo this. Put the P5. And we can put the auxiliary force there with either one. So anyway, we'll call this 1, and we'll call this one 1, 9. Sorry about that. Okay. And the left hand is hovering there waiting for the right hand, so it doesn't get any time for this. And so the combined time for this is going to be M1. Now I can put these together. P5, X4, or a total of 10. Okay. Now the next step of this is the left hand is going, or the right hand is going to transfer the cards with a clip to the third bin. So that's going to be an M4. What did we say that was? I can actually go back and look at my AutoCAD, and let's just see what that line was. That turned out to be a 21.4. So that's actually an M4 category. Okay, great. Again, this is where the AutoCAD is really helpful because it allows us to get those distances with some degree of, and that's not something we need to worry about here. That's our force. So this is going to be M4 P2 because we're arranging them neatly, but we don't have the constraints we had in the first one. Okay, and again, the left hand is going to start the next element. It can either start here or it could start at the same time the right hand reaches. So we'll just leave this blank for now for the left hand. So we're going to have 4, 2, and our combine will be M4 P2. And that's, oops, these all have frequencies of 1, 1, 1, 1, and total time of 6. So that completes our MODAPTS. It's a fairly simple operation. So we made this easy for you. Now, what you'll find is if you come down here, this should go ahead and give us the total time for the operation based on the total number of mods. So let's see, we said 27 mods. Let's see if this adds up. And always make a point to check this. These tables are easy to, this is a spreadsheet, and it's easy for the equations to become corrupted. So we got 7 plus 4, 11, plus 10, that's 21. And then we come down here, we got 6 or 27. So that adds up. So if you look at the formula in this, you'll see it looks kind of complicated. But basically what it's doing is it's taking the times for just the combined elements, not for the it doesn't take the total for the whole column. Okay, so there you have it. The next step that we'll do is to go through and look at the force requirements for each of these. And what this table will do then is allow us to enter the population strength, and it will calculate the percent MVC for us. And if the percent MVC is greater than 7%, it will actually calculate a time-weighted average for the workload during that time, and it will calculate the total time that the force is greater than that. And from that information, it can calculate what we call the duty cycle, which is the ratio of the work time to the total time. And we'll be able to use that to determine whether there's excessive risk of fatigue. Okay, so we'll start that with the next video.